In this video I'm going to show you how to simplify fractions. It's not at all that difficult, but I have to say you'll find it a lot easier if you've got excellent times table knowledge, if you're quite happy finding common factors. So that's if you can recognize when two numbers are both divisible by another number. And if you can do that quite easily, you're going to find simplifying fractions easy. And if you can divide in your head, then that's going to make life easier for you. You can divide on paper, writing stuff down, that's absolutely fine. But it will just take a little bit longer and you'll be slowed down. Okay, simplifying fractions. You may also see this written as reducing fractions. You may also see it written as cancelling fractions. They all mean the same thing, which is why it can lead to some confusion. But you've basically got three words: simplifying, reducing, or cancelling fractions. And what they mean is taking a fraction with larger numbers than necessary, dividing the top and the bottom by the same number to leave us with smaller numbers on the top and the bottom. And the advantage of having smaller numbers on the top and the bottom and yet still having an equivalent fraction is that it's much easier to kind of picture in our heads exactly the proportion that we're talking about. So for example, 150 over 200, okay, that when you simplify it can be simplified down to 3/4. Now in my head I'm not very good at picturing something divided into 200 pieces and then considering only 150 of them. I can picture though what 3/4 looks like, and that makes it far easier for me to make comparisons with other fractions. So for example, let's say, I don't know, there's a survey, 200 people are surveyed, 150 of them have excellent times table knowledge. Well, what does 150 over 200 mean to me? How do I compare that? Is that a good fraction? I don't really, it's difficult to picture. But if I see this as 3/4, and I know, I can visualize what 3/4 looks like, then the statistics from that survey are more meaningful to me. I can interpret them much more easily. So there's a reason for simplifying fractions. It makes it more straightforward to visualize and makes it more straightforward to do further calculations with as well. Let's say we were, for example, then going to try and do 150 over 200 plus 7/8. Okay, far easier if we were working with a smaller fraction but equivalent. So equivalent to 150 over 200, we said was 3/4. Far easier to go about working out what 3/4 plus 7/8 is instead of working with fractions that are using large numbers. Okay, let's get on with it. We're looking for an equivalent fraction to 8 over 48, but that uses smaller numbers. So we don't want to change the size of the fraction, if you like. We're happy changing the numbers, but only if we change them both by the same factor or multiplier so that we don't actually change the proportion. What does that mean? That means we need to find a number that goes into the top number that also goes into the bottom number. We need to find a common factor, okay, a factor of the numerator that is also a factor of the denominator. Right. This one's not difficult. Okay, they both divide by 2. Dividing both of them by 2 gives me a fraction of 4 over 24. Right. That has now been simplified. Okay, that's what I mean by simplifying, dividing the top and the bottom by a common factor. Now, I'm not saying that's in the simplest form. I'm going to save that for the next slide, but I have gone through the process of simplifying. I've simplified it once at least. Next one, 15 over 45. Both of these divide by 5. Okay, so when I divide them both by 5, I get 3 over 9. Right, that's now been simplified. Hopefully it's a little bit easier to picture what 3 over 9 looks like than it is to compare to think about what 15 over 45 looks like. Okay, last one. 27 over 36. Both divide by 3. Sorry, that squiggle is a 3. Let's do that a bit better. Right, if they both divide by 3, then the fraction I have after I've simplified is 9 over 12. Okay, simplified. Right. Now, you'd be wrong to think that you've done all the simplifying you can do with those 3 fractions. You can actually simplify them further. Okay, so let's talk about that on the next slide. Simplest form. You might also see this written as simplest form or lowest terms. Okay, if it says reduce a fraction to its lowest terms, that's the same as asking you to write the fraction in its simplest form. So what you tend to get is, it might say add 3/4 plus 6/8 and write the fraction in its simplest form. Okay, so you would come to some kind of answer and then you would have to simplify it all the way to the very end. Okay, what do I mean by that? Right, well, 48 over 72, we'll start by simplifying it, dividing top and bottom by 2. Okay, so 2 goes into the top and the bottom in this case. And I would get 24 over 36. Yes, it's been simplified, but no, I haven't written it in its lowest terms or in the simplest form. Why? Well, because this fraction, this new one, can be simplified further. Okay, so it's not in the simplest form until I cannot simplify any further. And what does that mean in practice? Well, that means that I keep simplifying until there are no common factors in the numerator and the denominator, except obviously for the number 1. Okay, 1 is a common factor of any pair of numbers, but we're not really interested in dividing the top and the bottom by 1. So let's think of another factor, okay, for 24 and 36. Well, you know what? These both divide by 2 as well. So that will give us 12 over 18. Yep, simplified, but still not fully simplified. Okay, I can keep going. 12 over 18, still both divide by 2 actually. What do we get? We get 6 over 9. Yep, that's simplified. But, and this is one of the mistakes that students often make, is to say, right, I've simplified it 3 times already. Surely that's the simplest form. Look, I can't divide these both by 2. Well, I never said, okay, that simplifying was only about dividing by 2. I always said that it was about looking for a common factor. So a common factor of 6 and 9 is 3. And what do you get once you've simplified that? 2 over 3, or 2/3. Right, that has been simplified. Let's ask ourselves again, are there any common factors of 2 and 3? No. Apart from 1, obviously. I'm discounting 1 because it's boring dividing both numbers by 1. I won't change very much. So the simplified form, the fully simplified form, so the simplest form of 48 over 72 is 2/3. So that took me, what, 1, 2, 3, 4 steps to do it. Okay, I simplified it 4 times. I could have done that in 1 step. Could have done that in 1 step using supreme times table knowledge. Okay, let's think of a bigger number that divides into 48 and 72. In fact, not just a bigger number, but let's find the highest common factor of 48 and 72. So that's the biggest number that will divide into both of them. 48 and 72, they both divide by 24. That's the biggest number that I can get in them. So if I divide the top and the bottom by 24, I do 48 divided by 24, gives me 2, and 72 divided by 24 gives me 3. So I could have done that all in 1 step. I'll just do that with a bit more space on the screen. Divide them both by 24 and I get 2/3. Okay, now not many people know their 24 times table, and I'm not expecting you to know your 24 times table. We could still have done it quicker. Then rather than dividing by 2, we could have divided certainly by 12. We really ought to know that both divide by 12. So what does that give us? 4 over 6. Right, from there, it's only one more step to divide top and bottom by 2 this time until we get to 2/3, our simplest form. Okay, so always try and go for the biggest factor you can think of, because it will just get you to the simplest form much quicker. Okay, so with that advice in mind, the biggest number that I can think of that goes into 18 and 27 is 9. And I get 2 over 3. Right, we've seen 2/3 before. We know we can't simplify any further. So that is 18 over 27 in lowest terms, or simplest form. 560 over 630. Now, this is something that you can do quite quickly when numbers are multiples of 10, like 560 and 630. Well, 10 is going to be a factor of both of them. Okay, if they both end in 0, it means they're a multiple of 10. In other words, 10 is a factor. Okay, so dividing both of them by 10, I'm going to get 56 and 63. So immediately, I've simplified that down to 56 over 63. Okay, but 56 and 63 is not the simplest form. I now need to think of numbers that go into 56 and 63. Well, with my knowledge of the 7 times table, I can divide both by 7, and what do I get? 8 over 9. Is that the simplest form? Okay, so I never assume that I've got down to the simplest form until I have asked myself the question and found that the answer is, yeah, you got down to the simplest form because there are no more common factors other than 1. Right, 8 over 9. Thinking of the factors of 8, thinking of the factors of 9, there's nothing that goes into both of those two numbers except for 1. So in that case, it's in the simplest form. Let me just show you what would happen if I did divide both of them by 1, just to prove that it's not interesting. 8 divided by 1 is 8. 9 divided by 1 is, sorry, 9 divided by 1 is 9. 8 over 9 again. Right, that was completely pointless. So unless you can find a factor of both numbers other than 1, then you have found the simplest form. Okay, so 560 in its over 630 in its simplest form is 8 over 9. Much easier to compare 8 over 9 with, say, 5 over 9 than it is to compare 560 over 630 with 5 over 9. That's the whole point of simplifying fractions. Okay, a couple of classic mistakes, and I've already kind of mentioned one of them. The first is that students assume that you can only divide by 2 in order to simplify. So let's divide by 2. We get 28 over 70. Dividing by 2 again, because at least the student has asked themselves this time, oh yeah, I can still simplify. Or can I still simplify? Yes, you can. Okay, so 14 over 35. Now I can't simplify anymore because this one's even. It divides by 2, but this one isn't even. It won't divide by 2. Except that, as I said before, it's all about common factors. It's not about whether it divides by 2. That's not the only common factor that ever exists in the world. So what do they both divide by? 7. So simplifying that, then I'll get 2 over 5. And I'm still going to keep trying to simplify. So I've got to ask myself, right, is there a common factor of 2 and 5? No, there isn't. Okay, other than the number 1, forget that. Okay, other than the number 1, there are no more common factors. So in which case, that is the simplest form. But I don't make any assumptions about that being the simplest form until I've asked myself the question, are there more common factors to find? Okay, and then the next classic mistake is really the same kind of thing. I can't divide by 2. What can I divide by? I can divide by 5. Okay, so dividing both of those by 5, I get 12 over 15. And then they say, right, okay, well, can't simplify any further. 12 over 15. We've got an even number and an odd number. Those both, both of those don't divide by 2. I can't think of any more common factors. Well, this is where your times table knowledge comes in. Because if you think that 12 and 15 don't have any common factors other than 1, well, you'd be mistaken in this case, because they do. 3 goes into both of them. What do I get then? I get 9 over, sorry, I don't get 9 over anything. I get 4 over 5. I'm going to ask myself yet again, because I'm never convinced until I've got the answer, no, there are no more common factors. 4 and 5, any common factors? No, not really, other than 1. So in that case, that is the simplest form. Okay, so just to be really clear about the classic mistakes that people sometimes make. One is that they think you can only ever divide by 2 in order to simplify. Well, I've shown here that that is not the case. The next classic mistake that they make is to think they've fully simplified when they can't think of any more factors. They would say to me that 12 over 15 is fully simplified. However, they haven't considered other options. Okay, so 3 was a factor of 12 and 15, which allowed me to simplify further. Okay, so do keep checking your final fraction and ask yourself, are there any common factors of the numerator and the denominator? And if there are, divide again. If there aren't, you've got your simplest form. Okay, that's the end of that video. I hope that picks up some more marks for you in the exam. Bye.